Welcome, Recruit. Today's explainer is literally your day one mission briefing for mastering Linux. Let me tell you, this isn't just another operating system. It is the undisputed OS of cybersecurity. Seriously, if you want to be a major player in this field, this is exactly where it all begins.
Now, you might be wondering, hey, why are we focusing so heavily on Linux? Well, it's because roughly 96% of the web servers that you're going to be attacking, defending, or testing out there in the real world, they run on Linux. Let that sink in for a second. 96%. You simply can't avoid it. And honestly, the sooner you get comfortable here, the faster everything else in your career is going to accelerate.
Okay, let's dive straight into today's briefing. We've got a really clear roadmap. We're going to cover why Linux is absolutely crucial, set up your isolated virtual lab, map out the battlefields of the file system, learn your weaponized daily commands, decode file permissions, and then wrap up with a drill on why practice makes perfect. Let's get moving.
So, Section 1, the OS of cybersecurity. Let's look at the environment itself and figure out exactly why the security industry relies on it so heavily.
Unlike the consumer operating systems you're probably used to, Linux gives you full open source visibility. That means you can understand the system at a deep, fundamental level and actually trust what you're running. Plus, you get this incredible ecosystem of over 600 security tools built natively right into it. And the scripting power? Oh man, between Bash, Python, and command chaining, you can automate almost anything. In this field, manual repetition is for amateurs. Now, when you're choosing your distro, you've got a day one decision to make. If you're brand new to all this, start with Ubuntu. It's way more forgiving, and it really teaches you the operating system properly from the ground up. But keep your eyes on the prize. Your ultimate destination is Kali Linux. It's Debian-based, just like Ubuntu, so the commands are exactly the same, but Kali is the pre-armed industry standard. It comes loaded with all those pen testing tools we just talked about. All right, moving right along to Section 2, building your virtual lab. Before we even think about touching any live systems, we need to issue your gear and build a safe, isolated environment using a virtual machine, or VM. You're going to follow these standard provisioning steps to create your lab for the next 90 days. First, grab VirtualBox. It's totally free. And download the Kali Linux installer image. When you create that VM, make sure you provision it with at least 4 gigabytes of RAM, 50 gigs of disk space, and 2 CPU cores. Boot the whole thing up, run through the standard installation, and this is key. Run your system updates immediately using the command line. So, here is a critical habit you need to form right now. Take a VM snapshot. Just name it Clean Install. Do this before you install any new tools, and absolutely before you run any exploits. Think of a snapshot like a save game. If you break something, and trust me, you will break things, you can just revert back to this clean state in about 10 seconds, instead of spending hours reinstalling the whole shebang. Okay, Section 3, mapping the Linux file system. Now that your lab is ready to go, let's look at the map of the battlefield. Linux organizes absolutely everything, files, devices, processes, into one unified hierarchy starting from root. Think of the root directory, which is just represented by a simple /, as the foundation of a massive building. From there, it branches out. Take the /etc directory, for example. That's your critical control room. It holds system configuration files and passwords. Then you've got /var/log, which is essentially your security camera footage showing all the authentication events and errors. And then there's /tmp. Now, this is like a chaotic public lobby that happens to be world writable. We'll get into why that's so important in just a second. This setup brilliantly illustrates the attacker's mindset. When a threat actor actually gets a shell on a system, they don't just wander around aimlessly. No, they use an attacker priority list. They head straight for /etc shadow to see if they can read hashed passwords. They'll check the bash history in the /home directories to see exactly what commands users have been running. They scan /varww for database credentials hiding in web configs. And yep, they use that world writable /temp directory as a staging ground. Why? Because they don't even need elevated permissions to write their malicious payloads there. Moving into Section 4, essential navigation commands. To move effectively through this map we just drew, you've got to learn the grammar of Linux. These aren't optional, folks. These are your daily navigation and reading commands. These basic commands are your movement controls. PWD stands for Print Working Directory. It basically tells you exactly where you are when you inevitably get lost. CD changes your directory, letting you actually move around.
And ls-la? Oh, that is going to be your absolute best friend. It lists everything in a directory, including all the sneaky hidden files that start with a dot, and gives you the full, long format of permissions. We're going to decode that very soon. Once you navigate to a file, well, you need to read it. Use cat for a quick dump of short files right into your terminal. If you're hunting for hard-coded secrets hidden inside an executable binary, strings is your go-to tool to extract readable text. And tail.f, that one is incredibly powerful. It lets you watch live logs update in real time, which is absolutely perfect for monitoring an active attack exactly as it happens. Next up is Section 5, decoding file permissions. Specifically, we're decoding that ls-la output. This is a totally crucial skill, understanding exactly what you are allowed to touch, read, and execute. Let's break down this detailed ls-la output. When you run the command, that string of characters on the far left instantly tells you the file type, whether it's a regular file, a directory, or a link. Then it shows the RWX permissions, read, write, and execute, and it breaks this down for the file's owner, the group, and then everyone else. Literally, at a single glance, you know exactly who has the power to modify a critical system file. Now, within those permissions, pay very close attention to the SUID bit. If you spot an S instead of an X in the owner's execute position, that binary runs with the owner's privileges, no matter who actually calls the command. If the owner happens to be root and you find this on some unusual binary, alarm bells should be ringing in your head. That is a prime privilege escalation opportunity, just waiting to be exploited. All right, Section 6, practice makes perfect. Let's transition into our final phase and see how all of this builds into your actual fieldwork and your daily habits. Your assignment today is completely hands-on. I need you to set up your VM, explore those critical directories we just mapped out, and use commands like tail to read the auth logs. But most importantly, practice decoding those ls-la file permissions on real system files. Honestly, all this knowledge is completely useless without actual application. To really master this, you need to run every single one of these file management and navigation commands in your own terminal. Don't just read them, type them out. Understand what every single line does. Create a file, move a directory, delete a test payload. Just keep repeating them until they feel entirely natural to you. Which brings us to the day one pro tip. Listen, you can understand a command perfectly. You can know exactly what a tool does in theory and still be painfully slow typing it out during a high-stakes engagement. Speed of execution comes from repetition, not just from understanding. Manual repetition in your lab is literally the only way to build the muscle memory you are going to need for this job. So, here we are. Your virtual lab is built, armed, and ready. Your map of the Linux file system is drawn, and you know exactly where the targets and the traps are. So, open your terminal right now. What is your very first command going to be?